So let's do an example here. So this is the universal set, and we have three subsets of the universal set. So we have to form some new set. The first one, A union B, A union C. So C is not obvious. They have written it down, but we can figure out what multiple means. Multiple means division divided by 3. So from here, that can be divided by 3 is 3, 6, 9. So these three numbers can be divided by 3. So we need to form a new set which is A union C. So give the braces, remember. So A is 1. So then we have the set C. Set C is 3. So we write 3. We write only one 3. We don't write two. Two threes. So then we have 5. Then we have 6 here. Then we write 7. And we have 9. So we write only one 9. So that is A union C. Next, intersection common. So B intersection C. So B is this set. So what is common with B and C? How many of these numbers are multiples of 3? So well, we have 6, and that's all. We have only one element here that is multiple of 3, so 6. Now A union C prime. So A union C prime means from the universal set you have to remove A union C. So this is universal set. So from that we have to remove A union C. So what we have to remove? We have to remove 1. So we don't have to remove 2. So let me write 2 here. Then we have to remove 3. We don't have to remove 4 because 4 is not here. So let me write 4 here. Then we have to remove 5, 6, 7. We don't have to remove 8. And then we don't have to remove 10. So that's how it works. So here we have the universal set, and we have prime numbers, factors, and multiples. Okay. So first of all, what are the prime numbers? Let me use different colors to denote prime numbers. So let me use red. So let me use red for prime numbers. So prime numbers means a number greater than 1 that cannot be divided by any other number but by itself. So and 1. So we have 23 as a prime number. We have 27 is not a prime number. 29 is 27. We have 29. So we have two prime numbers over here. 20 is not a prime number. 21 is not a prime number. So we have only two prime numbers here. Now factors of 360 means, let me use brown. That means which is divided any number by which you can 360 divided by that number is another integer. So we can divide 360 by 20. We can divide it. So we can divide 360 by, we cannot divide it with 21. We cannot divide it with 22. We can divide it with 20. I don't think we can divide it with 24 either. So let's check. So 360 divided by 24, 15. Oh, we can divide it with 24. So we have this. Then we have 25. 360 divided by 25. That is not, we don't get an integer. So 26 is not possible. 27 is not possible. 28 is not possible. 30 is possible. Multiples of 4 means numbers with which you can divide 4. So we have 20, we can divide it with 4. We have 24, we can divide it with 4. We have 28, we can divide it with 4. That's it. So now let's start. So first of all, P. So we can write here. So the set P is going to be, prime number set is going to be red. So it's going to be 23. It's going to be 29. So there are two prime numbers over here. But notice that there is a small n. There is a small n. It means we don't want to know the elements of the set. We just want to know number of elements in the set. So the answer would be np equals to 2 because there are only two elements in the set. F union M, that means this one. So we have to write everything that there is. So F union M, write everything that there is. So for F, we have 20. So M is also 20. So we write 1M, 120. Then we have 24. That's also common. But we want to write everything that there is. Then we have 28. So that's in M. We have to write that, 28. Then there is 30. That is in factor of F, factor of 360. So we have to write that also. So F union M means you write everything that there is in F, everything that there is M, but do not repeat the one that is coming twice. Just write it once. So we have this universal set, and this time they are giving this using a notation. This means that set A is 2 and also greater than 2. That means 3, 4 and 5. So 2, 3, 4, 5. That's all what it means. Then set B means factors of 24. So we need numbers with which we can divide with 24. So we have 2, 2 12s are 24, we have 3, 3 8s are, we have 4, 4 6s are, we have 6, 6 4s are, and we have 8, 8 3s are, and that's it. These are factors of 24. Then we have prime numbers from always checking from a universal set. So the prime numbers are, we have 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, that's all. So these are the prime numbers. Now we have to write the set B. So set B we have already written. It's going to be 2, 3, 4, 6, 8. Then number B, A intersection C. So A intersection C means what are the numbers from 2 to 5 that are prime numbers? Well, we have 2, we have 3 and we have 5. So these are the common ones. Now we have to make a union of these two sets. So B union A intersection C. So use the previous two sums. Write everything that there is, but do not repeat. So you have to write 3 ones. So there are 2, write 1, 2. So 3, 3, write 1, 3. So then we have 4, then we have 5, we have 6, we have 8. So we are writing everything once. So 2, 3, 4, 5, 6, 8. Okay, the next one. So union of everything prime. So that means A union B union C prime. So you take everything in A, everything in B, everything in C and remove them from the universal set and write whatever there is. So let's see. So we cannot write 2, 3, 4, 5. So let me cross it out here so it is more clearer. So I cannot write 2 here. I cannot use 3. I cannot use 4. I cannot use 5. So this is removed because prime means it cannot be in any of the sets. Okay. Union means we have to take, so be 2, 3, 4, 6. It cannot be 6. It cannot be 8. So these are removed. In set C, we have 2, we have 3, we have 5, and we have 7. So whatever is left is 9 and 10. So that these are the leftovers. So 9 and 10. Now suppose we have a set D. Let me call it set D, and which is 9, 10. Okay. So this is the set. Suppose I call this set D. Okay. Now we have set C, and we have prime numbers. So the prime numbers are 2, 3, 5, 7. Now if they ask you to write down C intersection D, remember there is no intersection at all, so it's an empty set, so this would be the notation.